Hello friends, I am Agrawal, Assistant Professor in Civil Engineering Department, Sandipani Technical Campus, Latur. Our today's topic is analysis of 3-inch parabolic arch. Learning outcomes. After watching this video, student will be able to calculate the support reactions and also student will be able to calculate the internal forces. Now, this is numeric. A 3-inch parabolic arch of span 20 meter and rise of 4 meter carries uniformly distributed load of 20 kN per meter on the left half of the span. Find the radial shear, normal thrust and a bending moment at a section 6 meter from the left support. Now first we draw the loading diagram. So here 3-inch arch. So first we draw the arch. Three arch here. This is the left support. This is the right support. This is the third hinge. The first hinge you add here because of hinge support. This is the support hinge A, B and the C. Now this is subjected to UDL of 20 kN per meter on the left half. So here apply the UDL on left half portion and intensity is the 20 kN per meter. So here show the intensity 20 kN per meter. Now the first step is to calculate the reactions. So for that we here consider a simply supported beam for our sake of convenience, because always here is a beam plus the H. So here and this intensity is the 20 kN per meter. Now here the span given is the 20 meter and this rise is the 4 meter. Now this reaction is the VA and this reaction is the VB. So for the calculation of reactions, so apply the sigma MA condition. Sigma MA is equal to 0. So add here we are considering the clockwise positive and the anti-clockwise negative. So moment about this A. So here this load is in a clockwise fashion. So 20 into span is a 10 because this is a 10 meter into the then minus 20 VB is equal to 0. So we got here VB is equal to 50 kN. Then apply here sigma Fy condition. Fy is equal to 0. So VA is upward is plus, then plus VB is upward is plus, and that load is minus 20 into 10 into the 20 to 10 total load. And that is equal to the 0. So we know here this VA is unknown, VA, then VB is the 50 minus 200 is equal to 0. So we got here VA is equal to the 150 km. Then next is to calculate this horizontal reactions, because at the support here one horizontal reaction at here is H, and so here is one H. This is the VB that we have calculated, and this is the VA. So VA and VB we got here. VA is equal to 150 and the VB is equal to this 50. So unknown is now the H value. So for the H, we have to take the bending moment at the crown. So bending moment at the crown, bending moment at the crown, because there is a hinge and that is equal to 0 because of the hinge. Because here at the C, here there is a hinge. There is a hinge. That is why here bending moment is the 0. So we are taking from the left hand side, suppose. So what here? The bending moment is, first is always B moment. So B moment minus the H moment or thrust moment, and here this is equal to 0, so that is equal to the 0. So B moment is this. This is what VA, that is equal to the 150, and this VB is equal to the 50. So from the left side, and we are taking bending moment at here at the center. So VA creates the second bending moment. So 150 into the 10. Then this load is create this UDL, create the Hawking bending moment, so minus 20 into 10 into 5. And then H moment is minus H into the, here we are taking moment at here, this point. So this is H into this H. How much is H? Is a 4 meter. So into the 4 is equal to 0. So we got here H is equal to 125 meter. So in this way we got the value of the H. Then here this VB, then this VA, now next is our aim is to find what is the given is find the radial shear, normal thrust and the bending moment. So now here we calculate the normal thrust. Now for the normal thrust, that is the N, and that is equal to, formula is the B sin theta plus H cos theta. So here we know the H. So unknown is the what? Theta and this V. So V is equal to is a shear force at now. But where we want a normal thrust? At the 6 meter. So we want the shear force at 6 meter. So at here suppose it's 6 meter. So shear force at this location. So that how calculate? So here the V is equal to How this V? VA. From left hand side, VA is a positive and this UL is a minus. So that V is equal to VA minus 20 into the 6. So that is equal to the 30 kN. Now in this way we got the value of this V. That is equal to 30 kN. Now next is the theta. So how to calculate the theta? Now for the parabolic arch, we know anywhere this y is equal to 4hx divided by L square into L minus x. Now this dy by dx, and that is known as the tan theta. So that is equal to 4h by L square into L minus 2x. Now x is where we want the radial shear of normal thrust. So here x is equal to the 6. Now 4, h is equal to the 4 divided by 20 square, L is 20 minus 2 into the 6. So here we got theta is equal to 17.76. So now here in previous equation, what is our unknowns? At here this V and this theta. So we got the V is 30 and theta is equal to the 17.76. So here we can write N is equal to V is the 30, V sin 17.76 plus H is equal to 125 cos of 17.76. So that is equal to 128.19 km. Then next is the Q, that is called as the radial shear. That is equal to V cos theta minus H sin theta. So we know V is equal to 30 and cos 17.76 minus H is 125 into the sine of 17.76. So here that is equal to minus 9.51 kN. So this Q is equal to, in this way we got the value of the Q also. And the previous one is the normal thrust. And finally we want here the bending moment. Now in the problem given is what asked is again the bending moment at section 6 meter from the left support. Now here again here we want the bending moment at this location at 6 meter. Now at here this is our x. Suppose this is, we want the bending moment. Now the bending moment at 6 meter, suppose. So bending moment at 6 meter is equal to, always is what, a B moment minus the thrust moment, or we call it as H moment. Now first we write the B moment. So B moment here at here, B moment. B moment is here, is what, VA into the 6 is a sagging bending moment, and this is the hogging bending moment. What, 20 into the 6 into the 3. That is a B moment. Or suppose here we draw like a beam, and this is the medial, 20 km per meter, and at this location we want the bending moment. This is 150. So this create the sagging bending moment. So 150 into the 6, then minus, because this usually create the hogging bending moment. So minus 20 into 6 into 3, then minus h is equal to 125 now into the y. Where is the y? Now, this height is we call as the y. So how to find this y? For the parabolic arch, this y is equal to, for the parabolic arch, the y is equal to 4hx divided by L square into L minus x. This is for the parabolic arch. So here y is equal to 4, h is equal to the 4. Now x is equal to the 6 meter, because we want the bending moment at 6 meter. So 6 divided by the 20 square, 20 minus 6. So that is equal to 3.38 the meter. So we got here the y. So put this in this equation, y is equal to, so bending moment at 6 meter is equal to 150 into 6 minus 20 into 6 into 3 minus 125 into 3.38. So this is equal to 117.50 kilonewton meter. So here we got the value of bending moment. So this is the asked into our problem, that is bending moment at 6 meter, then radial shear at 6 meter, and the ground thrust at the 6 meter. So this is the complete problem. Thank you.